So one more example where I want to find the interval of convergence for a power series. So this time it's the sum from 0 to infinity of 2 to the n times x plus 1 to the n over n factorial. And so I'm going to start this the same way by noting where this power series is centered. So remember, the general form for a power series is Cn x minus a to the n, where the center is a. So this x plus 1 to the n we could think of as x minus negative 1 to the n. So this is a power series centered at negative 1. So we know for sure the interval of convergence at least includes negative 1, because every power series converges at its center. Okay, so we know that much. Now where else does it converge? That's the question. So I see a factorial, I'm going to go to ratio test. And take the limit as n approaches infinity of the absolute value of the n plus 1 term, so 2 to the n plus 1 times x plus 1 to the n plus 1, replace all of the n's with n plus 1's. N plus 1 factorial. All of that over the nth term, where you just copy what you see. Okay, but that's pretty messy, so I'm going to bring this up, multiply by the reciprocal, and I'm going to save as much room for myself as I can this time. Learn my lesson for once. So limit as n approaches infinity. Let's see, so I'll put the absolute value on this. So numerator, 2 to the n times 2 to the first, x plus 1 to the n times x plus 1 to the first, okay, over n plus 1 factorial. I'll leave that alone for now. Okay, and multiply by the reciprocal of what's down here. So times n factorial over 2 to the n, x plus 1 to the n. Okay, so here's the fun part. Things cancel. 2 to the n cancels. X plus 1 to the n cancels. And now look for expressions that no longer involve n. So the 2 here, the x plus 1 here, can both move outside. Just be sure that you take their absolute value. So this is equal to absolute value of 2, which is just 2, times the absolute value of x plus 1. These terms do not care about n approaching infinity. They're not affected by that limit. But then times the limit, so what's left? What is affected by it? So we've got n factorial over n plus 1 factorial, right? And that's all that's left. I'm not writing the absolute value anymore because these are always positive. N is a positive integer. Now, remember, ratio of 2 factorials, leave the smaller one alone, expand the bigger one. So this is equal to 2 times the absolute value of x plus 1 times the limit as n approaches infinity of, so leave the smaller factorial alone, expand the bigger one. So n plus 1 factorial we can write as n plus 1 times n factorial. And so that cancels. So this numerator now is just 1. And so we have the limit as n approaches infinity of 1 over n plus 1. Well, so that's 1 over infinity. That's going to 0. And so times this stuff out front, but so this limit's just going to be 0, no matter what value we have for x. So now if x is 500, then still we're going to have 2 times 501 times 0. So the product's going to be 0. So the limit's going to be 0, which is less than 1, for every value of x. So ratio test tells us that the series converges no matter what value we have for x. X can be as big in magnitude as we want it to be, and we know we're going to end up multiplying by 0 in this limit. So the interval of convergence in this case is negative infinity to infinity. This power series converges for all values of x. And if you're asked about the radius of convergence, capital R, in a scenario like this, we say that the radius of convergence is infinity.